Let's go ahead and calculate a reaction rate. This is screencast 13.3. We'll do a sample problem, and while we're doing it, we'll think about what we need to know in order to calculate a reaction rate. And we'll think deeper and ask ourselves, does that reaction rate that we calculated tell us everything we need to know, or are there things it's not telling us? Are you ready? Okay, here we go. Here's a sample calculation. We're neutralizing some hydrochloric acid, so we're reacting it with sodium hydroxide. That's going to make some salts and some water. The initial concentration of the hydrochloric acid is 0.22 molar, and after 4 seconds of adding the sodium hydroxide, it's down to 0.1 molar. It looks like it's more than halfway complete. Let's go ahead and calculate the reaction rate using that data. Now realize that there are some limitations here. It's only telling us the reaction rate with respect to hydrochloric acid. It didn't tell us anything else. And also it didn't tell us what happened after 4 seconds. Is the reaction to continue at that rate? You don't know. It'll only tell us the information based on the data we have. Anyhow, we know that it's simply the change in concentration, in this case of hydrochloric acid, over time, and let's see, if it went from 0.22 to 0.1, it sounds like the change is 0.12. The time is obviously 4 seconds. 0.12 over 4 is 0.03. And look at the funny units that come out. Mole per liter per second. Now, if you think about it, since the ratio is 1 to 1 to 1 to 1, that would be the rate for that time for any of these things appearing or disappearing. But if the ratios are different, you're going to have to recalculate and say, oh, the rate of the reaction with respect to appearance of sodium chloride is blah, blah, blah. Also, you probably should say for that time interval, because you're not talking about the entire time of the chemical reaction. Also, I suppose you should also include that during that reaction rate, that's the average time for that rate. It might have gone much faster and then slowed down. You're not assuming that it's going at a steady pace. You're just given that data, and that's what you get. That's a sample calculation for the rate of a chemical reaction.